Hello, algebra class. Hope you guys are doing well, doing just fine. Today we are going deeper into the quadratic equation. I'm going to be starting with some tips and then a couple things that we can look at to describe. Yeah, I'll get into that later. We don't need to worry about that right now. Let's get started. Actually, before I do that, I've scheduled 12.6 for both today, Wednesday, and tomorrow. There's also a quiz that comes with 12.6. Today I'll do the notes. Tomorrow I'll have the video for the quiz. So keep an eye out for that. You might look at the homework and say, oh, but I don't know how to do the quiz. That's okay. You have an extra day. I'm spreading this out because it's a dense topic. Okay. I'm also giving you guys more chance to email me or write comments below, none of which I've heard from you guys. So we'll get on that. Now, without further ado, let's jump in. So the quadratic equation. I mentioned this yesterday, that when we have any type of quadratic equation, we can choose the best way to solve it. Yes, the AC method, diamond problems, is the easiest form, right? We could just find the factors, bada bing, bada boom. Doesn't always work. Sometimes we could do completing the square. I have a hard time with completing the square. It's not so natural to me. It does have really nice benefits, right? Because that b over 2 term is the other, it's the factor. Boom, right there. But that's not always the best. What I always recommend is trying the AC method, and if that doesn't work, then do the quadratic formula. So try number 1. If that doesn't work, boom, just go straight to the quadratic formula. It'll get you there. Here's a tip. If our b equals 0, isolate the x squared and use the square root property. So for example, if we have x squared minus 121 equals 0, well, just isolate it, take the square root, and there are your factors right there. Again, that's if we don't have any b term, no x term. So it's x squared minus a constant, minus a number. That's when it's best to do the square root. Here's another tip. If the polynomials factor easy, solve by factoring. That's the diamond problem. So if we have, for example, x squared plus 2x minus 3 equals 0, well, again, this is where you try first the AC method. Oopsies. You try first the AC method. Where was I? You plug it in, and you figure out right away that these are your factors. So we know that x equals, once we set each individual term to 0, we'll get x equals negative 3 and x equals positive 1. Easy peasy lemon squeezy. Okay. Although, of course, it doesn't always work like that. And in those instances, use the quadratic formula. Again, the quadratic formula, our x intercepts, or our x terms, our zeros, will be negative b plus or minus the square root of a whole lot of business. First b squared minus 4ac, all divided by 2a. Okay. Yes, it is my goal to get that stuck in your head, so that way when you guys go on to be successful mathematicians, you'll still be singing that stupid little ditty, and you'll have me to blame. Okay, now I want to talk about this term that's called our discriminant. Now, this isn't discrimination. This is the discriminant, and this is a way that we can describe our equation. We could describe the ax squared plus bx plus c. We could describe that with this discriminant. Now, the discriminant is the business that's under the square root. So that's the b squared minus 4ac. This is our discriminant. And the discriminant tells us the number and types of solutions. I've got, pardon me, allergies. I've got a few different, I think there's 4 different scenarios. So if our discriminant is greater than 0 and it is a perfect square, like 49 or 121, then we're going to have 2 rational solutions. Our 2 zeros are going to be integers, counting numbers. I have some examples down below. This is the first scenario. The second scenario is it is greater than 0, but it's not a perfect square. That means we're going to have 2 irrational solutions. That's where it's like the b plus or minus the square root of something divided by another number. So do you remember all these where we had 5 plus or minus the square root of 13 or plus or minus the square root of 12 or whatever, all divided by 3. It's like that just doesn't really work. And so this would be scenario 2, where our discriminant is positive, but it's not a perfect square. The third scenario is when our discriminant equals 0. That means we have 1 rational solution. It might be a fraction, but a fraction is still rational. It might be 1 over 4 or something like that. But that's still rational, right? That would be our b, our b plus or minus 0 divided by some other number. So then this is just the solution. And then this fourth scenario is where our discriminant is less than 0. And that's when we have no real solution. Now I've drawn up on my handy dandy little whiteboard what this fourth scenario looks like. This fourth scenario, we still have a quadratic equation, but it never crosses the x-axis. Whether it's in this quadrant, both quadrants, or sometimes it'll be like this. But it never touches the x-axis. Now, if we have just one solution, like that's the third scenario, then, our vertex is going to be on the x-axis, like so. This is, this is scenario number 3. These are both scenario number 4. Okay. Hope that makes sense. That's just kind of a quick visual. I do have examples that we'll get to in just a second. But again, these were scenarios 3 and 4, where we have 1 rational solution or no real solutions, right? Because it just doesn't work. Yeah, you can't take the square root of a negative number. All right, let's get to some of these examples. So this would be scenario 2. Oh, I'm sorry, this would be scenario 1, where we have 2 rational solutions, right? It'd be 1 plus 5. 1 plus 5 divided by 4, which is 3 over 2. And 1 minus 5 divided by 4, which is -1. Right, so we have two rational solutions, 3/2 and -1. Scenario number 2. These are two irrational. We can't take the square root of 13. So 1 plus the square root of 13, whatever that is, it's 3 point something divided by 4. So it's 1 plus 3 point something divided by 4, and then 1 minus 3 point something divided by 4. I don't know what it is. We just leave it like that. That's our answer. So when your discriminant is positive, but it's not a perfect square, this is your answer. Looks ugly, but it's easy mathematically, right? We don't need to do this extra stuff. Okay. This is scenario 3, where our discriminant is 0. We have one rational solution, right? In this case, x equals 1/4, right? It's 1 plus 0/4, 1/4. So at this point, 1/4, 0, that's where the x-axis, the graph intersects the x-axis. Boom. Okay, so it's just something kind of quick like that. Then we've got these guys. Okay. That's just a quick sketch, but it's kind of straightforward. And then, again, our fourth scenario. So we still have a graph here, but it does not intersect the x-axis. Okay. So this is about halfway through our notes, which is why I'm taking 2 days to do this. I'm going to continue on with this video. It's going to be a long video, but if you wanted to pause, now would be a good time. All right, now that we're back, we're going to use the quadratic formula and solve for the discriminant to describe the solution. And by describing it, it's pretty simple. So we're going to take our A, B, and C, we're going to plug it in. Right, so this is the business underneath the square root, 1 squared, right, b squared minus 4ac. So 1 squared minus 4 times 4, that's going to be 1 minus 16, which is -15. That's going to give us, that's scenario number 4, where we have no real solutions. So this would be how you answer that question, right, because we've got b squared minus 4ac, and so it's scenario 4, no real solutions. Okay, next step. I've got one more page of notes, and with this, we're going to write the quadratic equation in standard form with given solutions. So basically, we're going to be given some type of solutions, and then we need to work backwards. Now, you don't need to do the whole quadratic formula backwards. That would be difficult. That's not what we're doing. It's actually a lot easier than that. So we're just reversing the steps. First step, we're going to write each of them separately. Right, so I've got x equals 5, x equals -7, and then I'm going to set them equal to 0. So I'm going to bring everything onto one side of the equation. And these are both of my factors in that case. This times that equals 0. And here we FOIL, that's step number 2. First one's outside, inside, last. And then step number 3, we combine our like terms. Right, again, this is the first one, outside, inside, last, after I multiply all these. Then I combine my like terms, and I end up with my quadratic equation in standard form. See, not too difficult. Not too difficult when we have integers like 5 and -7, but there will be times where we have fractions. The first step with these is to write separately and then to multiply each of those by the denominators. Here's what I mean. So let's say we have x equals 2/3 and -1/4. Well, I'm going to write these separately, and then I'm going to multiply both sides by my given denominators. So x equals 2/3, and I'm multiplying both sides by my denominator. Then x equals -1/4, and I'm multiplying both sides by 4. That's going to eliminate my denominator, and it just makes this whole process a whole bunch easier. This is what I end up with. Now again, I'm going to bring everything to one side of the separate equation. Now I'm going to do what I did up here. I'm going to bring them together, FOIL. That's going to give me 12x squared plus 3x minus 8x minus 2. I'm going to combine my like terms. That should say combine. And I'm left with my quadratic equation in standard form. Okay. I have 2 more that I have written here as practice problems. I'll leave these up to you guys. Go ahead and work on them. Please, if you have any questions, either comment on the video below, or you could email me. I would love to hear from you guys, honestly. If not, I'll just assume that you're doing well. Again, I'll be back tomorrow with the video on the quiz. And if I don't hear from you, just know that I love you. Bye, guys.